Okay, let us assume that we have an object like this, and there are multiple forces acting on this object. Suppose one force is acting in this direction, like your applied force is in this direction. The weight of the object is acting in downward direction, and normal force is acting in upward direction, and friction force is acting in this direction. Air friction, that's a ground friction suppose, and air friction is also in this direction. So now you can see there are multiple forces acting on this object simultaneously. So now we need to calculate the total force acting on this object. So in order to calculate the net force or total force, we need to add these vector quantities. When these vector quantities would be added, the whatever the result will come, that would be the net force acting on the object. So in case of so we have two different scenarios. The first scenario is whether the forces are acting parallel or non-parallel. So first case is the case of parallel forces acting on the object. Parallel forces means parallel or anti-parallel. Parallel and anti-parallel means, suppose you have an object like this, and one force like this is the driving force, one force is acting in this direction and second force is acting in the same direction. Let's assume that this force is 10 Newton and this force is 6 newtons. So these two forces, when we have parallel, are okay. This is one case. Another case may be when two forces are acting anti-parallel. I mean to say that suppose 10 Newton force is acting in this direction and 6 Newton force is acting in this direction. Okay, so you can see 10 Newton force is comparatively large than 6 Newton, so I draw a large arrow and a small arrow for 6 Newton. Similarly for 10 Newton it is little larger than this one, which is 6 Newton. So when the forces are parallel and we are going to add them, there is a very simple algebraic, then we are going to add them algebraically. Suppose the net force or resultant force is like both are in same direction, so you are going to add them. For same direction we will just add them and the resultant would be 16 Newton. But in case when you have opposite directions you will subtract them. Then in the second case, the resultant would be 10 Newton is in one direction, and for opposite direction we are going to put minus sign. Okay, so our resultant force would be 4 Newton. When we have parallel forces or anti-parallel forces, then in that case we will just use algebraic method, like simple we do in algebra. Simply add them or subtract them. By like addition would occur in when forces would be parallel, and subtraction in case of anti-parallel. Okay, second scenario is when forces are not parallel. Non-parallel forces. Non-parallel forces means, suppose you can see, suppose we have an object and different forces are acting on it. Suppose one force is acting in this direction, and some other force is acting like this. So in such case we cannot use the algebraic method. Then we have two other options. So let's discuss them one by one. So we have two different options. So first option is head to tail method. Head to tail method. And second method is called parallelogram method. So we have two different methods. One is head to tail method and second is parallelogram method. So let's discuss them one by one. This is the case when we have non-parallel forces. Okay, let me draw it in a simple way. And we have two forces acting on an object. Suppose one force is acting like this, and second force is acting like this. And we are talking about head to tail method. So in case of head to tail method, what is the strategy? The strategy is just simply move one vector and put it to the head of other vector. Okay, now you can see this is the head of first vector and on head of first vector we put the tail of second vector. So here is the head of one vector and tail of second vector, that's why it is called head to tail method. Okay, so now when you will add these two vectors, then you will get the resultant vector. So the result or total vector answer would be a new vector that would start from the tail of first vector and ends at the head of second vector. So this vector is called resultant vector. Okay, so this is our head to tail method. So you can do a reverse procedure as well. I moved the green one, you can move the purple one as well, suppose like this. So the purple one, green one is was initially here, and if you want to move this one, you can do it like this. The answer remains same. The resultant is same in both cases, whether you drag the one vector to the head of other vector, first vector to the head of second vector, or second vector to the head of first vector. The resultant remains same. So this method is called head to tail method. Okay, parallelogram method. In the parallelogram method is quite similar to head to tail method. See how, suppose we have a vector like this. This is our first vector and this is our second vector. Okay, so in case of parallelogram method, we actually generate the replica of a vector. Replica means photocopy of the similar vector. Let's draw a vector like this. Suppose its replica vector or image vector would be of same size. I'm gonna draw a image vector of this one. You can see the image vector of this is like this, and then I'm gonna put parallel to it, like see these two vectors, this one and this one, like the dark blue is actually the image vector of this original vector. Similarly, you will draw an image vector of the black one. This is the image vector like this. Okay, you will put it somewhere here. Okay, so the image of black is black and the blue is blue, light blue is dark blue, suppose. So now you can see, by doing this we have made a parallelogram. It's a parallelogram. So now vectors are added like this, and then you will draw a resultant vector which will start from the tails of first two vectors, where two vectors have tail, and will end where two vectors have their heads. This is the resultant vector, and the method is called parallelogram method. Okay, either it's a head to tail method or parallelogram method. Suppose we have one like first vector is 10 newtons, second vector is 8 newtons. Okay, so then we will scale these vectors. Scaling means, like on a paper we cannot use the newtons, we will use centimeters. So suppose 10 newton on in terms of force would be would be 10 centimeter. This is my scale on a paper. Similarly, 8 newton on a in terms of force would be 8 centimeter on a page. Okay, so I'm gonna draw this one as, suppose this is our 10 centimeter in length, this is suppose 8 centimeter in length, which is actually in newtons. Now when this one would be 10 centimeter, this is 10 centimeter, this is 8 centimeter. Now suppose the resultant is, now you will use the scale to find out the length of this vector, and suppose it is 16. This 16 represents the length, the resultant vector. So our resultant would be 16 newtons now. So this is how we find out the resultant vector by parallelogram method. Same procedure can be applied in case of scaling. Same scaling can be used in case of head to tail method as well.